Chapter 7, Fitting Multivariate HGLMs. We have two sections. First sections, multivariate HGLMs, and last sections, missing data problems. In this chapter, we show the general multivariate models can be generated by connecting double HGLM where various response with correlated random effect. Let's take an example by using the ethylene glycol data. Following by Price et al. In 1985 presents data from a study on the development toxicity of the ethylene glycol in mice. You have two responses with binary, malformations, and for continuous data, vital weight. This table represents our informations. We have dose, dams, leaf, number of malformations and percent, weight, mean, and standard deviance. For just most from each dam, let Y1Ig denotes vital weight and Y2Ig denotes an indicator for malformations. Then we can write our YIg, which is Y1Ig, Y2Ig transpose, be the bivariate response. Let Vi can be written by Wi Ui transpose be the observer's random effects for each cluster and assume that Y1Ig and Y2Ig are conditionally independent given Vi. Therefore, this figure represents path diagram for the multi-HGLM fitted to the ethylene glycol data. We have 1x drug, we have 2y, y1 for weight, and y2 for malformations. And we have W and U for the connection. We propose following bivariate HGLMs as follows. Y1Ig with conditions Wi, following normal distributions with mean Wig and variance C. And our second, Y2Ig with conditions Ui, follows the Bernoulli with the Pig. And we can write our mu Ig, x1Ig beta 1 plus Wi. Our logits Pig, x2Ig beta 2 plus Ui. And our Vi, Wi Ui transpose, follows normal distributions with mean 0 and variance metric covariance. With the metric covariance like this, and we have -1, less than rho, less than 1. At the same time, we have three types of model series. M1 leads independent random effect with rho 0. And model 2, random effects with a shared parameters Ui, delta Wi for some constants delta. And 3, random effect with a saturated variance covariance matrix. Subsections 2, missing data problems. Analysis of missing data requires handling of unobserved random variables, and this should be a natural area of applications for extended likelihood. Suppose some values in Y are missing or unobserved. We write our Y obs and Y missing, where Y obs and Y missing denote the observed and missing data respectively. Then the join of Y is given by F theta Y, Y obs, Y miss. Here we can consider a factor of missing indicator R, such that Ri1 if 1i is missing, 0 if yi is observed. Then we have bivariate observed data, y obs and R. Suppose observed data are missing at random or MAR. This means that the probability of being missing depends only on y obs. Under missing at random, we have F theta lambda, Y obs R, F theta, Y obs, F lambda R with conditions Y obs. And to make you understand, we will keep in practice. Open the albatross. Click multivariate response analysis. Correlation structures independent. Model forming. Response variable Y1, select those and those two as independent variable, random effect liter, and respond to. With the response variable y2, select the those and those two. Random effect return. The distributions for random effect Gaussian. The distributions binomial with link functions will get. Click run. We have two output here, response 1 and response 2. Click model checking plots to see our residuals for every single variables, every single parameters, both from the response 1 and response 2. See the table likelihood CIC to measure the accuracy. Change the correlation structures correlated and click run. The results will be slightly different. Click data import and choose error data. We choose the rheumatoid arthritis. The rheumatoid arthritis patients report onset reaction study or RAPPORT study. The longitudinal study that aims to identify an increase in disease activity by self-report questionnaire. More detail. This variable consists 3 y variable y1 dash 20i. This data consists 3 different y, y1, y2, y3. So we have time, age, sex, and subject 159 patients. And we can write our y, ig, y1 ig, y2 ig, and y3 ig transpose. Response from JIT visits for the 8th patients start from 1 until 159, and our G 1 until 5. XK leads as design symmetric for the kit response, as the covariate we use to intercept time, age, and sex. These figures represents the path diagram for the MDHM fitted to the rheumatoid arthritis data. First, we can consider the following multivariate model with the 3 response. Y1ij with conditions V11i, Vy2i follows the normal with the X1ig beta 1 plus V11 plus V12 time and C. Y2ig with conditions V21i follows the Bernoulli. Same like Y3ig with conditions V3i1 follows Bernoulli. The model for DAS20i includes a random intercept and slope, while HIQ and Radai have only random intercept. We assume a 4-dimensional latent structures like this. To example, click multi-response analysis. Response variable y1, select the time, age, sex as independent variable, random effect subjects, click random slope models, random slope, time, and click response to, response variable, y2, select time, x, sex, random effects, subject, distributions binomial and functions logarithm. For response 3, select response variable, y3, independent variable, time, random effect subjects, independent variable, time, x, sex. Click run. And our output will be appear like this. We have 3 model. Model 1, model 2, and model 3. Click model checking plot to see our model from all response. The next example, National Merit Scholarship Qualifying Test, page 185. National Merit Twins data, including extensive questionnaires from 139 adult sense twins, who took the National Merit Scholarship Qualifying Test, or NMSQT, with 1982, among the roughly 600,000 US high school juniors. They were diagnosed as identical, 509 pairs, or same-sex fraternal, 330 pairs, by a brief mail questionnaire. Later, they completed a 1,082 time questionnaires covering a variety of behaviors, attitudes, personality, life experiences, health, vocational preference, etc., plus the 48-item California Psychological Inventory. Twin score on the NMSQT and their 5 subscales are also included. The 285-item questionnaire filled out by the parents was mainly focused on the life histories and the experiences of the twins. This data including for Y, we have Y1, Y2, Y3, Y4. For NMSQT scores recorded within 0 until 100. English for Y1. Mathematics Y2. Social science Y3. And natural science Y4. At the same time, we have 5 different independent variables. X1 for gender, X2 for the mother's educational level, X3 father's educational level, X4 for family income level, and X5 for zygosity. This figure represents the path diagram for the MD diagram fitted to the MSQT for twins data. We consider a multivariate HGLM with 4 response variables for the jet persons of the eighth twin for the K 1, 2, 3, 4. We can write our models Y Kij with condition V Ki follows and Xij beta power mu K plus Vk theta Kij, where the random effects follow the multivariate hormone distributions Y this matrix. To allow heterogeneity between type of zygosity, we consider the model for residual variance with log C Kij equals beta power C K0 plus beta power C K5x x5i. On the other hand, random effects of social science and natural science scores show the strongest correlations with 0.78. The correlation between English and mathematics scores has the lowest value, 0.622. For gender effect, men have a higher significant scores on mathematics, social science, and natural science, but women have higher significant scores on English. Mother's educational level is not significant at almost all subject scores, but father's educational level 4 and 6 are significant. Family's income level 5 has a significant positive effect, and it has the highest estimate. In the Dispersion models for residual variance, we see that fraternal twins have greater heterogeneity than identical twins. From these figures, we see that normal probability plots are approximately linear in the absence of the outliers. Thus, the fitted model is satisfactory. Open the albatross, click multivariate post-analysis, select our response variable y1, select for independent variable x1 until x5, check V, for response 2, model for mean y2, select the independent variable s1 until x5, the random effect Pelnam, model for V click use, select y2, response 3, select response variable y3, independent variable s1 until x5, the random effect Pelnam, and seems like response 4. Click Run. for response 1 until response 4. Click model checking plot to see scatter plot of our residual. Lee, Nader, and Pawitans in 2017 considers the vascular cognitive impairment or VCI data. The VCI measurements are increased among the stroke patients because cognitive function is declined due to the stroke. However, through an early interventions based on VCI, the cognitive functions can be improved. The purpose of the study is to examine the effect of 10 demographic and 10 acute neuroimaging variables on the cognitive functions in the ischemic stroke patients. Therefore, we have 4Y, Y1, Y2, Y3, and Y4. Y1 for executive, Y2 for memory, Y3 for visual-spatial, and Y4 for language, with the ID 372 patients. And this table represents the information to all variables. These figures represents the path diagram for the MDHGLM fitted to the VCI data. Consider our multivariate HGLM for response variable for the third visits of the 8th patients for K 1, 2, 3, 4. And the random effects follow a multivariate normal distribution. From these figures, we can see many large outliers. MDHGLM1. We consider a multivariate DSGLM called MDHGLM1 for the allows a habitat distributions for Y K80 with conditions VKI for K start 1 until 4 as follows. For MDHGLM1, we have log theta KIT beta power C K0 plus V power C KI. And for MDHGLM2, we have log lambda KI beta power lambda K0 plus V power lambda Ki. And these figures represents about the normal probability plot. To measure the models, CAIC selects the MGLM2. We see that most outliers in the multivariate HGLM disappearing by using MDHGLM1 or MDXGLM2. Open the Vascular Analytics, click Multiple Response Analysis, MDHGLM, select the reference variable Y1, select the independent variable X1 until X20. Select random effect, ID, our V, use, random effects, random effects ID, and lambda, use, random effect, ID, click Run, and we will get our models like this. Click model checking plot starts from response 1 until response 4. To check the scatter plot of our residual versus fitted. This data is longitudinal datasets from the Mother's Stress and Children's Morbidity Study or MCM. Therefore, we have two Y, Y1 for stress and Y2 for illness. We have variables marriage status, high educational level, employment status, race, gender of the children, health status of the children at the baseline, health status of the mothers at the baseline, household size, the average stress values, and the stress illness values, and the study time. We will employ the bivariate Bernoulli HGLM. With the YIG, Y1 IG, Y2 IG transpose for the bivariate binary response for the jet visit for the 8th family. And VI power mu, WI power mu, UI power mu transpose for unobserved random effects for the 8th family. Y1 IG with condition VI power mu follows the Bernoulli. with the V2 Ig with conditions Vi power mu, and follows the Bernoulli P2 Ig. Now we can write our models like this. Keep in mind that we're given Vi power mu and we first consider the three models with the log lambda I1, beta 10 power lambda, and log 2i beta 20 power lambda. M1 independent model having rho 0. M2 random effect model with the saturated variance covariance matrix. And lastly, M3 share random effects models having ui power mu, delta yi power mu for some constants delta. And we can get the values of CIC for the M1, M2, and M3. Thus, the CIC selects the full model M2 among the three models. Regarding the robust bifariate HGLM in binary data, GLM MMs are sensitive to the distributional assumptions of the random effects, which is difficult to identify. Thus, we consider the robust bifariate HGLM by allowing random effects in the variance for random effects. And lastly, the CIC selects M4 as the best fitting model. Open the albatross. Select the response variable stress, independent variable, merit, education, employee, race, C sex, CX, LTH, MH LTH, host size, B stress, and B illness. Select random effect ID. Click run, and we will get our model like this. Here's the estimate for a mean model. Click response to. Click model chicken pack to see the scatter plot, the residual versus fitted. Next example, primary, biliary, Cirrhosis. Look at this data longitudinal datasets in the R package GM, followed by Comaris in 2015. From a Mayo clinical trial on 312 patients with a primary biliary hemorrhage or PBC conducted in 1974 until 1984. There are 1 to 5 visits per subject performed at the time of months. At each visit, measurements for the three response variables are observed. This data including the subject, the day, month, Y1 for the continuous logarithmic bilirubin, Y2 discards platelet count, Y3 dichotomous indications of the blood vessel malformations. These figures illustrate the path diagram for the MDHGLM fitted to the PBC data. We consider a multivariate model for three response variables with the covariate XIT for the fifth visit of the each patients like this, where the random effect follow multivariate normal distribution. These figures represents the model checking plots for multivariate HGLM for Y1 and Y2 on the primary biliary hemorrhage data. We can see that under the multivariate HGLM, many large outliers exist. And we can write our multivariate DHGLM allowing the heavy type distribution for Y1 and Y2 like this. We have log C1I and log C2I. The CIC shows the DHGLM is better fit than XGLM. We can see that many outliers in multivariate XGLM disappear, allowing a heavy-tailed distribution for Y1 and Y2 respectively. Thus, we select the DHGLM, which gives robust estimators against outliers. Open the albatross analytics, select response variable LBILI, select independent variable, month, random effect, subject, our fee, click use, select independent variable, month, response to, same like before, our response variables is platelet, Independent variable month, subject under effect, subject. For Y3, select the response variable, spiders. Independent variable month, random effect, subject. The distribution should be binomial. V, click use, select the response variable, independent month. Click run. And we will have model summary. Check response 1, response 2, and response 3. Also, click the model chicken plot to see the scatter plot the average dual versus fitted. In Chapter 6, we analyze the schizophrenia behavior data from an eye tracking experiment, with the visual target moving back and forth along a horizontal line on a screen, flowing by Rubin and Wu in 1997. We assume that the missing data are the missing at random or MAR. We propose using the DSGLM with like this. We call this model is DI, DSGLM with the ignorable missingness. The end, DSGLM with non-ignorable missingness. According to the physicians, missingness could be caused by eye blinks, which are related to eye movements or response. This leads to the following model for missing data, with the delta IG, Y2 IG indicators variables, 1 for missing and 0 for otherwise. We can consider the model DI as well as the end, with the probit model having two responses, Y1 for a continuous response and Y2 for a missing indicator. DI, DXGLM with ignorable missingness where rho 0, and the end, DXGLM with non-ignorable missingness where rho not 0. The negative value of rho hat supports the second options that lower values of the response are more likely to be missing at each cycle. However, the conclusions concerning non-ignorable missingness depend crucially on the untestable distribution assumption. Thus, sensitivity analysis has been recommended. Fortunately, the analysis of the response in their data indicates that they are not sensitive to the assumptions about the heavy tails or the missing mechanism, following by Yu and Lee in 2006. Lee, Nelder, and Palitan in 2017 considers the law school's admissions data of Book and Lieberman's in 1970, consisting of 6 items for law school's admissions tests with the 350 subjects. Y1 until Y6 leads as items for law school's admissions tests, 1 for correct and 0 for not correct, with the 360 subjects. And these figures represents the path diagram for the binary 2 factors model. One factor model. We also consider one factor model which is equivalent to assumes that correlations between V1I and V2I being plus minus 1. One factor model has CIC, which is less than two factors model CIC. Thus, CIC clearly prefers the one factor model. Upon the Robertos, click multiple response analysis. The factor models. The factor models. After set the values, click run, and we will get the model like this. And we get our lambda, gamma, beta, and the likelihood information.